In this video, I'm going to go through some counting problems. These are basically how many ways to rearrange certain words or the letters in words. First one here, we've got how many distinguishable ways are there to rearrange the letters in median. Now, this particular one is probably the most straightforward that we'll show you, and that's because all the letters in median are different from each other. So it's not like there's two M's or anything. Every letter just shows up once. So the way to do this, if we want to figure out how many letters or how many ways we can sort of rearrange letters in median, I'm going to walk you through sort of kind of building it up in some sense from scratch. Eventually, we'll want to be able to kind of just spit out the answer here, but you've got to see a few to kind of get the hang of that. So when we think about this, what we're thinking here is we have choices for each of 6 letters here. There's 6 letters in median here. And so this first letter, what we do is we could pick any of the M, the E, the D, the I, the A, or the N. They're really here. I'm just going to write 6 for 6 choices for the first letter. And then once we've picked the first letter, no matter which one we pick, there's still 5 left. So it turns out that for the second letter, we lost one of those. That's 5. So to get the first 2 letters here, you have 6 choices for the first letter, 5 for the second. That'll end up being a multiplication here. And then the third letter, well, you've already taken 2 of the letters away. That means there's 4 left. So you multiply by 4. The fourth letter, you've taken 3 of the letters away. There's 3 left, or 1 less than 4. So 6 times 5 times 4 times 3 for the first 4 letters. The fifth letter, we would multiply by 2, 1 less than 3. There's only 2 letters left after we've already removed 4. And then this last one, we can kind of write a 1 or not, I guess, because multiply by 1 doesn't change anything, but there's sort of just, hey, it's the last letter left. So you get 6 times 5 times 4 times 3 times 2 times 1. If we want to actually do the multiplication here, let's see, I'm going to do it this way. 5 times 4 is 20. 3 times 2 is 6. So we get 6 times 20 times 6. 6 times 6 is 36 times 20. That's 720. Okay, so there's 720 ways to rearrange the letters really in median here. Now, thinking about doing this a little more quickly, this took, not really that long here, but this is kind of a common pattern, is how many sort of ways can we rearrange this. This is called a permutation here. So this is really the number of permutations, which is just sort of rearranging, but a sort of fancier math term, of n objects, and these are n distinct objects, here. And that is, well, it's this, if there are 6 objects, it's 6 times 5 times 4 times 3 times 2 times 1. So that's a common thing. This is a factorial. So this is 6 factorial. We do an exclamation point. So 6 with an exclamation. This is verbalized as 6 factorial. And this is just 6 times 5 times 4 times 3 times 2 times 1. Times 1. There we go. And in this case, that's 720. All right, let's go to the next one. Okay, so how many distinguishable ways are there to rearrange the letters in maximum? So this one's a little bit different because those M's are repeated. So if we look at this, what we have is 3 M's. We have 1 A. We have 1 X. We have 1 I. And we have 1 U. 3, 4, 5, 6, 7 letters. 1, 3, 4, 5, 6. Yep, that checks out. 7 letters here. All right. So what's going to happen here is if we pick an M the first time, there's sort of 3 different M's to choose from. So this sort of complicates what we're doing. You might think, oh, there's 7 letters, just do 7 factorial. And that's not quite the case, because what happens here You do your 7 factorial to like rearrange the letters if these are like separate blocks. But then what you have to do is, amongst those blocks, you've got the 3 m's. You can rearrange the 3 m's here. So you really get 7 factorial divided by 3 factorial here. And this 3 factorial is really, you sort of, whoops. Three factorial is you want to be able to rearrange the 3 m's here. Is why you divide by that 3 factorial. So now what we get, this is 7 times 6 times 5 times 4 times 3 times 2. I'm going to leave off the times 1. And then times 3 times 2 on the bottom. We can cancel the 3 times 2's. And so we get, let's see, 7 times 6 is 42. 5 times 4 is 20. So we end up with 840. Okay. Here, I just want to show you something to kind of generalize this that'll be a little bit safer, really. What we could do instead is we could do the 7 factorial over, well, we do 3 factorial for the m's, but then what about the a's? Well, there's only one a, so that's times 1, whoops, times 1 factorial, and there's 1x, which is times 1 factorial, and 1I, which is 1 factorial, and 1u, which is also 1 factorial. Now, 1 factorial is just 1, and so this is really 7 times 6 times 5 times 4 times 3 times 2. I'm going to write out the 1 this time just to be explicit. The first 3 factorial is 3 times 2 times 1. I'm going to get a times 1, and another times 1, and another times 1, and another times 1. And so the difference here is, in this blue, when I did the 7 factorial over 3 factorial, I didn't write out the sort of times 1's here, because these all just sort of cancel away because it's multiplying by 1. So it didn't really affect the answer at all. You get the same answer either way. I just want to point out this method in green because it sort of helps generalize and think about things. We could have done the same thing on the previous problem with median. We could have done 6 factorial divided by 1 factorial times 1 factorial times 1 factorial with 6 of those 1 factorials on the bottom, but that's just dividing by 1. It doesn't change anything. All right, last one for this section here. We're going to look at how many distinguishable ways are there to rearrange the letters in minimum. Okay, so that method in green here, this is going to help out, because what's different here is we're repeating more than one letter. So minimum, we have 3 m's. There's the i's. There's 2 i's. So this is the difference here. There's 3 m's and 2 i's. So repeated more than one letter. There looks like there's 1 n and then 1 u. I always like to count these to make sure I didn't miss anything. 3, 5, 6, 7 letters there. 1, 2, 3, 4, 5, 6, 7 letters in minimum here. All right, so this one, going through the sort of green method from previous, if we think about it, it's just really 7 factorial is the number of ways to rearrange 7 letters altogether, and then the m's we want to rearrange here. So this is like saying you could rearrange the m's here, and you get the same answer either way. So this is really, that divide by 3 factorial is distinguishable, is what it's talking about here. So that's the m's. And then I would do 2 factorial for the i's, and then I guess we could do a 1 factorial for the n's, and another 1 factorial for the u's. Again, 1 factorial is just 1, so you can omit those. So what we get is 7 times 6 times 5 times 4 times 3 times 2. Really times 1. I'm going to start leaving those off. I'm going to leave off my 1 factorials. 3 factorial is really 3 times 2 times 1, and then 2 factorial is just 2, or 2 times 1. All right, so now 3 times 2 is 6, so I can cancel a 6 with the 3 times 2, and 2 and 2 cancel. This is probably a good rule here, too, is to cancel all these things out. With these sort of counting factorial problems, a lot of cancelization can occur. In principle, you could do 7 times 6 times 5 times 4 times 3 times 2, multiply that all out, and then divide by 3 times 2 times 2, which is 12. So that would work. It's just sort of less efficient and probably a bit more error prone. Although, if you're doing it on a calculator, not so bad probably. Okay, but let's actually get a number here. So now 7 times 5. I'm going to do 5 times 4 separately, so I get a thing ending in 0. So I'm basically going to rewrite this as 7 times 3 times 5 times 4. And then 7 times 3 is 21. 5 times 4 is 20. And we end up with 420 in this case. So note, we had 7 letters here. We had 420. The previous question, we also had 7 letters. We had 840. If we go back up here, 840 was the correct answer here. What's the difference is that we had sort of 4 singleton letters with the 840, but with the 420 answer, we had 2 singletons and 1 letter paired up. So that divide by 2, that's really the 2 factorial here. That's really your divide by 2 and why you got that difference.